Hey guys, so this is flood fill algorithm. Um, you can easily do this with breadth first search, depth first search. We're gonna using breadth first search because this is breadth first search series. Um, okay, so how we gonna do this? So I mean, you're kind of familiar with flood fill. If you're not, just read the question. The point is like you just kind of explore one if you the neighbors you just color with the same color. You should understand the question, but anyway, the key insight to this question is how well, first the step is to kind of convert it into a tree, right? Visualize this as a tree, which is kind of like intuitive. I think hopefully that's kind of intuitive for you. So you start with one, and then you got four options you can move, right? Four directions you can move, like to the left, to the right, which is zero, or uh, to like up or down, right? Up the row or down the row. Um, Actually, this should be zero. I think one should be zero. Down should be zero. So this should be zero. Yeah, once you kind of do the tree, and now it's literally like, okay, let's visualize this in terms of queue, right? A queue, but then we're in this series, we're kind of learning to visualize it as a 2D queue, like a 2D structure, right? It will kind of look like this, right? First add one the root node, which is one, and then this is zero. This is zero, right? You visit one, and then you kind of go visit uh, the next level down, which is like 1 0. This is the order of the queue, right? This is how we press it. And I think that's pretty much it, really. There's nothing towards it, and then just do a simple breadth first search. Go there, and I think the only edge cases to be aware of when you kind of are doing this like traversal, like in a grid, is be aware of these edge cases. X and Y, the cell being out of bound, like so when you're accessing the X and Y coordinates, right? Just make sure it's in the cell it exists. And the second one is like the X and Y, the cell is not already visited, right? So what I mean by that is like when you're processing this particular cell or this particular node, right? Um, you can easily, so when you're processing this particular node over here, right, you can easily like one of the option is its parent itself, right? So that's the tricky bit, I would say. I think if you just do this question once and just kind of bear in mind, oh, there just make sure this set is not visited, this the previous cell was not visited, because you can easily uh, add it and kind of have this infinite loop going on. All right. Well, okay. So this is the coding solution with those insight. Um, I mean, it kind of looks very generic, right? Like, you got the breadth first search, very generic setup. Like, you got the levels. I'm imagining a 2D grid again, with the nested loops. I mean, and then you're kind of iterating over this particular row or that particular level, and then popping things out. And again, when we're processing at this inside this for loop, we're kind of processing that particular row or that particular level, right? So I mean, there's usually two things we do, right? We first like do some like processing. We process that node. We process the node that we just popped out, and then we add children, right? We add the children to the queue or the 2D structure, right? So yeah, process the cell. Um, you know, So the first process the cell, change color. This is literally it in this algorithm, and then just add the children to the grid, right? Um, and this should not be too complex. It's adding the children. Just find out what the children are, and the trick over here is to kind of add the valid children, right? Like I said, the valid children being is in bound, is within the bound, right? The X and Y is within the bound, and they're not visited. And if that's the case, then you just add it to the 2D structure. Yeah, that's pretty much it, to be honest. And you set obviously because I think adding to the set might be when you check this particular, it's a constant time, so that's really good. Um, yeah, I mean dy row, this particular code, just make. I mean, this is another pattern. Just like use dr, drdc, like as their derivatives, like unit derivatives, to kind of like make it easier, make your life easier over here. So make your life easier to kind of make it, create the position of where the children is located. So yeah, um, that's pretty much it, really. We submit this, should run, uh, and yeah, submission okay. Again, the key insight is just kind of turning this into a tree, and then kind of looking at as a 2D structure, and just thinking about these edge case when, because this is a problem for grids. So just thinking about these two edge case, um, and we're good. Thanks.